Okay, let's jump right in. We're going to talk about a really remarkable technology called non-invasive prenatal testing, or NIPT for short. And we're going to look at a super precise version of it that uses something called dPCR. It's completely changing how we can understand a baby's health right from the very beginning, all from just a simple blood test.
You know, it's true, isn't it? Every single pregnancy has its own unique story, a really complex narrative of growth and development. And forever, those earliest chapters have been a total mystery.
And that's the big question, right? For the longest time, getting a clear look at a baby's genetic health meant procedures that were invasive, and because of that, came with risk. So what if there was a way to read that story without ever bothering its author?
Well, it turns out the answer is, kind of remarkably, written in blood. And that brings us to our first chapter, figuring out how the mother's own bloodstream is carrying the very secrets we're looking for.
So this is the messenger. It's called cell-free DNA, or cfDNA. You see, as the placenta is doing its job, it naturally sheds these little tiny fragments of its DNA, which, by the way, is genetically identical to the baby's, right into the mother's blood. It's kind of like finding a secret message in a bottle, just floating in a huge ocean.
So how much of this message are we actually talking about? Well, by the end of the first trimester, about 10% of all the free-floating DNA in an expecting mother's blood actually comes from the pregnancy. That is the signal we need to find. It's faint, but it's there, and that's all we need.
Okay, so we've found the signal. The next obvious question is, how do we read it with real, absolute precision? And this brings us to the hero of our story, digital PCR. This is the incredible piece of tech that can actually hear that faint whisper of the baby's DNA amongst all the noise from the mothers.
And this just perfectly shows the huge leap forward we're talking about. Think about it like this. Traditional methods, they're kind of like looking at a blurry photograph. You get a general, fuzzy, averaged-out idea of what's going on. But digital PCR? Wow. That's like seeing a super high-resolution image made up of 20,000 individual, crystal-clear pixels. You're not getting an average, you're getting an exact count.
Okay, so how on earth do you create these pixels from a single drop of blood? Let's get into the mechanics of it. This is where the real genius of the technology really shines.
First off, you gotta understand the scale here. It's just massive. We're talking about taking one single blood sample and partitioning it into about 20,000 microscopic droplets, and each one of those becomes its own tiny separate experiment.
So here's how it all breaks down. You start with that one simple sample. Then the magic happens. You partition it into these thousands of tiny droplets. Then, and here's the cool part, each little droplet is analyzed all by itself to see if it has the specific genetic marker we're looking for. Finally, all the results from all 20,000 of those droplets are put back together to give us that complete and incredibly precise picture.
So, with all this incredible tech, what does it all come down to? I mean, how does this become something that's actually useful? Well, after all that partitioning and analyzing, it really just boils down to one simple but incredibly powerful action: counting.
Okay, so here's the deal. For any given chromosome, let's take chromosome 21 for example, we know what a normal or expected count should look like in a healthy pregnancy. With dPCR, we can measure the actual count. So if that measured count is statistically higher, like you can see pretty clearly in this chart, that is an incredibly strong sign of a trisomy, like trisomy 21, which you probably know as Down syndrome. We're talking about an accuracy rate of over 99% for detecting the specific condition. It's just that precise.
And here's why this is such a game changer. Because dPCR is literally counting individual molecules, one by one, across thousands of these tiny reactions, it is just so sensitive. And that is absolutely vital, because sometimes the amount of the baby's DNA in the sample, scientists call this the fetal fraction, can be really low. This technology can still pull out a clear, confident result.
And this brings us right back to where we started. Remember that question, how can we read the baby's story safely? Well, this technology delivers on that promise, and it gives expectant parents two of the most important things you could ever ask for.
So for parents, what does this all mean? Well, it boils down to these huge benefits. First, and most importantly, there's absolutely zero risk to the baby, because it's just a simple blood draw from the mother's arm. The results are incredibly accurate, which really cuts down on the chance of those false alarms that cause so much stress and anxiety. It provides clear answers, non-invasively.
There's a quote that just sums this all up perfectly. This isn't just some generic test. It's a tailored, highly specific look at an individual pregnancy. It really is the power of precision medicine, but it's applied to the most delicate and important time imaginable, the very beginning of life.
So when you see how a tiny blood sample can tell us so much, it really makes you wonder, right? If this is what we can do today, with this kind of safety and precision, what's coming next for non-invasive medicine? What other incredible stories are we going to be able to read?